Hello friends, welcome back to our channel. So today we will see one more concept in our compiler design, that is a storage allocation. So in our previous session we have seen about the symbol table and what are the entries that are available in the symbol table and how the symbol table can be implemented as well as the operations that can be performed on the symbol table. So now let us move on with the one more concept, that is storage organization. So here the name itself indicates storage organization means how efficiently we are going to use the memory. Okay, so without delay let us start the session. So storage organization. So here the name itself indicates storage organization means it is completely related with the memory. Okay, so that deals with how the memory was structured, and used to store programming elements. So I am generalizing this one, programming elements in the sense everything of a program. Okay, so we are going to use different variables, constants, and also local variables, global variables, static variables, okay, dynamic variables, any kind of the thing, right? So all these comes under this programming element. So how the memory was structured and used to store the programming elements during program execution. So program execution. So what we are calling program execution means this is a runtime environment. Okay, runtime environment. So now the memory, the complete memory is divided into four parts. The first one is code segment. Code segment, data segment, stack, and a heap. See, the complete memory is divided into four categories. So code segment, data segment, stack, and heap. Okay, so whatever the variables and whatever the programming elements we are going to use, everything will be stored in these four divisions. Okay, so coming to the code segment, what kind of things will be stored in the code segment? So here the name itself indicates is a code. So all the compiled instructions, so whatever the instruction that is being compiled, all those compiled instructions will be stored in this code segment. So compiled instruction in the sense, we are supposed, for example, let us take a C language. So we are supposed to write the main function. So whatever the instructions written in main function, okay, and in the main function, if you are using any user defined function called add, so whatever the statements of add, we are going to use some predefined functions like printf, scanf. So printf statements, scanf statements, etc., what not, all the compiled instructions will be stored in this code segment. Okay, and coming to the data segment, in this data segment, okay, all the static variables and global variables which are being declared in the program will be stored in this one. So static variables and global variables. Static variables and global variables. Apart from these, it will also store all initialized data and uninitialized data also. You might be knowing about this initialized data and uninitialized data. For example, if you consider int a, so this statement is just a declaration of variable a. So what is the value of a? So a we have not initialized any value, so this is an uninitialized variable. And what is the value of a means a garbage value. So for example, int b is equal to 20. So here both the declaration and initialization was there. So we have initialized some value to the variable. So the value of b will be 20. So these kind of variables can also be stored in the data segment. That means both the static variables and the global variables. Consider static and global variables. That too initialized or uninitialized data will be stored in the data segment. Coming to the stack. So working of functions, the function call. So whatever the parameters given in the function call, everything function call as well as a local variables, So these two will be stored in the stack, because see, for example, we say that we are writing some main function here. And after some instructions I have written some add, one more function and some other functions, and here we are writing some the function definition. What happens here? So the control will always starts execution from the main function, so it will start the sequential execution, and whenever the control executes this add, immediately the address will be stored in the stack. So the address of add will be stored in the stack, and immediately it doesn't move to the next instruction, it moves to the function definition, and here it will start again executing in a sequential manner. So whenever there it is a return or this closed curly brace, immediately it will pop the address from the stack, and it will again go back to the position from where it came here. So this is a position address of add, right? So this happens. So this is the use of a stack. That means that whenever there is a function, so the information will be stored in the stack itself. Similarly, whatever the local variables we are using, those local variables are also used in the stack. So whenever there is a function call, immediately it will create one activation record, and that activation record will be pushed into the stack. So usually we are saying that some address will be stored in the stack, but that's not the thing. Activation record will be pushed into the stack. So in that activation record, the address will be there. So we'll see about the activation record in our further session. Okay. So mainly the function call and the local variables will be stored in the stack. And coming to the heap, all the dynamic variables, allocation variables. So whatever the variables that are allocated dynamically, so we might be knowing the dynamic memory allocations like malloc, calloc, and realloc. So usually we will be allocating the memory during the runtime, okay, by using either malloc or calloc. So those kind of variables will be stored in this heap. Okay, so these are the four data segments which are being used to store the different programming elements during the program execution. Okay, so hope you understood this one. I'll give you one example, and I'll close it. Okay, so I'll write the example here itself so that you can understand. So I'll write some int a is equal to 10. int a is int a is equal to 10, and I'll write a main function here. Main function int b is equal to 20, and some add a comma b, and int star p is equal to int star malloc function. So I'm not writing the syntax, malloc function. So I'll, and then close, and again add int x comma int y, int z is equal to x plus y. So I'm writing this one, right? So hope you understood this program. So int a is equal to 10, and inside the main function int b is equal to 20. So I'm giving parameters. I'm passing the parameters to the add function a comma b, and I have taken one pointer variable, so it was declared here, and I'm giving the size here, size of int. Okay, so I'm not writing the complete thing, but I have used some malloc function to create a memory, allocate the memory to the variable, and in the function definition I'm taking two variables here. See, main function instructions, add function instructions will be stored in the code segment. Okay, main function, add function, and in the data segment, so what is this data segment? Static variables, global variables. So a is in a data segment. A is stored in the data segment because a is a global variable. And coming to the stack, function call and local variables. What is the function call? This add is a function call. So add will be stored here, as well as the local variables. Here the local variable is b. So here the local variable is b, and here you can see x, y also local variables, and even z is also a local variable. And add, everything will be stored in the stack. Everything will be stored in the stacks, both function as well as the local variables. And coming to the p, which is a malloc function, which where the address, I mean the memory is allocated using the malloc function. So p will be stored in the heap. P will be stored in the heap, right? So hope you understood this one, and I think it's clear. So which part of a programming element will be stored in a different data segments, I mean different segments, memory segments, right? So let's stop here, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.